Hello everyone, welcome to High Tech Study Plus. In today's video, we will be discussing certain basics of organic chemistry. Basically, we will be discussing the nomenclature of elements, which will be helpful for class 12 students. Class 11 can watch it as well. So let us begin. The IUPAC name of an organic compound, it consists of three things. First is the root word, second is prefix, and the third is suffix. Now the root word depends upon the number of carbon in the longest chain. If there is one carbon in the organic compound, then we use the word meth. For 2 carbons we use eth. For 3 carbons we use prop. For 4 carbons we use but. For 5 carbons we use pent. For 6 hex. For 7 hept. For 8 oct. For 9 non. And for 10 dec. After finding out the longest carbon chain, it is important for us to find out what are the suffixes and what are the prefixes that we will be using in this organic compound. Now, suffixes can be divided into two kinds, primary and secondary suffix. The primary suffix basically tells us about the saturation or unsaturation of the organic compound. If all the carbon in the given organic compound contain single bond between carbon-carbon, then we use the suffix ane, ane. And if there is a double bond anywhere, we use the suffix ene. If there is triple bond, we use the suffix yne. Now, secondary suffixes and the prefix depends upon the priority list of the functional groups. In an organic compound with more than one functional groups, whom are we going to prioritize, or which carbon is going to get the least number in the carbon chain? Let us begin. The first is COOH, carboxylic acid, then SO3H, sulfonic acid, then COOR, ester, then COCl, acid chloride, then CONH2, amide, then C triple bond and then CHO, aldehyde, then ketone, then alcohol, followed by SH, thiol, followed by NH2, amine, followed by C double bond C, C triple bond C, alkyne, followed by C single bond C, alkane, followed by ether, followed by halogens. Halogens here, X refers to chlorine, fluorine, bromine, iodine, followed by NO2, nitro. Now let us try to name the given organic compound which has two functional groups. One is COOH and OH. From the priority list, we know whom to prioritize. We will be giving the least carbon number to that carbon which has COOH. So, suppose there is a compound S3C, CH2, CH, here OH is attached, CH2, COOH. We can see here that the longest carbon chain is the straight chain and it consists of 1, 2, 3, 4, 5. 5 carbon atoms. So our root word becomes pent. We can see that there is single bond between the carbon atoms. And we know that we will be prioritizing COOH, and the suffix for COOH is oic acid. Since there is single bond, we will be writing ane. And in the first position oic acid is attached. We can see here that there is another group OH, but since we have prioritized COOH, OH becomes our prefix now. We will be using its prefix in the naming. Now the prefix for OH is hydroxy. We can see that it is attached to third carbon. So we will be naming it as 3-hydroxy pentanoic acid. Since it is attached in first position, I ignore this one. So I will be writing 3-hydroxy pentanoic acid. let us try to draw the structures of the haloalkanes that has been given in our book. First is 2-chloro 3-methyl pentane. First of all, start by drawing the number of carbon atoms. Here the longest chain consists of 5 carbons. So 1, 2, 3, 4, 5. N indicates there is single bond. So I do not need to convert these single bonds into a double or a triple bond. So this part is over. Now in the third carbon, we have to attach a methyl group. If I start by naming it from the left, this becomes the first carbon, second, third, fourth, fifth. In the third carbon, CH3 is attached. So this part is over for us. In the second position, chloro is attached. So to the second carbon, I will be adding Cl. Now our job is over, but now we have to complete the tetravalency of the carbon atoms. Here carbon has formed only one bond, so there will be 3 hydrogen here, H3. Here there are 3 bonds already, 1 H will be here. Here there are 3 bonds, 1 H will be here. Here there are 2 bonds, H2, and here there is 1 bond, so H3. Well, the next question is asking us to draw the structure of 1-chloro 4-ethyl cyclohexane. Now here hex indicates us that there are 6 carbon atoms, but the word cyclo indicates that the 6 carbon atoms are attached in the form of a ring, and we can represent 6 carbon atoms by a hexagon. So this is our hexagon. So our part of drawing a cyclohexane is done. Since no ene or yine has been written, I am not drawing any double or triple bonds. In the fourth position, ethyl group is attached. If I mark this carbon as 1, this becomes 2, 3, 4, 5, 6. I'll attach C2H5 ethyl group here, and in the first carbon I will attach chloro. So this is the structure of 1-chloro 4-ethyl cyclohexane. Next, let us draw the structure of 4-tert. Tert refers to tertiary butyl, 4-tertiary butyl 3-iodoheptane. The root word hept suggests that there are 7 carbon atoms. So 1, 2, 3, 4, 5, 6, 7. If we start assigning numbers to our carbon atoms, this is 1, 2, 3, 4, 5, 6, 7. To the third carbon, iodine is attached, I. To the fourth carbon, tertiary butyl is present. If a carbon atom is like this is a primary carbon. This is a primary carbon. If in an organic compound a carbon is attached to 2 more carbon atoms, then it is a secondary carbon. If a carbon atom is attached to 3 carbons, then it is a tertiary carbon. As the name indicates, tert butyl. This means we'll be using this structure here at the fourth position. So this becomes C, here CH3, here CH3, and here H3C. So this becomes our structure. But before that, we have to add the number of hydrogens so as to complete the tetravalency of carbon atoms. Here H3, here it is H2, here just CH would suffice, here CH, here CH2, here CH2, here CH3. So this is the structure of our organic compound. The next question has asked us to draw the structure of 1,4-dibromo but2ene. First of all, we'll be drawing 4 carbon atoms because the root word is but. 1, 2, 3, 4. At second position, ENE has been written. This means in the second position, there will be a double bond. Start assigning numbers. This is first, second, third, fourth. To the second carbon atom, a double bond will be attached. In the first position and in the fourth position, bromines have been attached. Now we should not get confused that there are 2 bromine atoms attached to these carbons. At first position there is 1 carbon. At fourth position there is another carbon. This 2, 1 plus 1 makes 2. We use the word di here. So to the first carbon I will be adding bromine here, and to the fourth carbon we will be adding bromine here. Now the work is simple. We have to complete the tetravalency. Here CH2, here CH, here CH, here CH2. So our compound becomes Br CH2, single bond CH, double bond CH, single bond CH2, Br. The fifth question has asked us to draw the structure of 1 bromo, 4 secondary butyl, 2 methyl benzene. First of all, we'll be starting by drawing a benzene ring. This is a benzene ring. Okay. Now, let us first draw the structure of secondary butyl in the rough so that we can draw it very well. CH, CH2, CH3, H3C. This is our secondary butyl, and we'll be attaching it to the fourth carbon atom. So let us start assigning numbers. 1, 2, 3, 4. Here H3C, CH, CH2, CH3. In the first position, bromine will be attached. Br will be attached here. In the second position, methyl will be attached. CH3 will be attached here. That's all for today. In the next video, we shall be coming up with some more organic compounds of haloalkanes and haloarenes and the nomenclature. Thank you.